So, welcome back. We've got our ball and paddle. We have right now just a check collision, and the ball is including the paddle file, so that they can. The ball is aware of the paddle file. Okay. Shh. Shh. Hey, if you're not gonna work, then be quiet, please. So, what we're going to do is go into this check paddle collision, and this is where it returns true that they're hitting. So let's see out a line in here that's going to tell us how far the ball and the paddle are apart. So I am going to go, I'm going to go body, then I'm going to do the arrow get position, okay? And I only care in the X direction actually right now. I'm going to get the body's X position, and I'm going to subtract from that the paddle's X position. So P is the name of the paddle, but it has its own body, so dot body. Oops. And then I'm going to do the arrow for that one. So it's going to return the box 2D position. Now this doesn't auto type, which is kind of a bummer. But every time they hit, I should see how far away the ball is from the paddle. And since, let me see what that error is, get position with a capital G. That's why I love auto type. Okay, so every time they hit, it should tell me how far they are apart. I think the box is referenced from the center and the ball is referenced from the center, so that should be, did it not say anything? Boom. Okay, no problem. I forgot in here that I have, what did I do in here? I had this C out right here, right? Check paddle. So I'm just going to call that without saying C out so that I don't write down true or false every single time. But it will now C out if they do hit and tell me how far apart they are, I believe. Let's hopefully see. Looks like it's going to work there. Great. Okay. Okay, so if I kind of hit in the middle, you can see they're very close in the same X position, right in the middle there. See that? Now I've got, maybe I should put a end line there. Close that. Under my ball code, I forgot to put an end line. Put that. And, all right, so this is good. I've got a number. Let's hit right in the center and see how far they are apart. They should be about 0 points apart, right? There you go, a really small number. Now I'm going to hit the very right edge of my paddle and see what number that is. It's about 2.66. Remember, that's box 2D units. Those are meters. And then if I hit the very left edge, it's about probably minus 2.662. Getting closer to hitting the very left edge, so. Okay, so from that approximation, if I look in paint, right? Yes. I draw a little square. This is my paddle. Okay. If my ball is here, it's got a position of minus 2.6, give or take. If my ball's right in the center of the paddle, not the best location for the center, then my ball's got an X position of 0 meters. And so that's good. Write that down, please. Great. And if my ball is right on the right edge of my paddle, it's got a position of about 2.6 pixels. Great. Okay. I don't know if you can see that well. Zoom in a little bit for you here. So all I have to do is say, if that position is minus 2.6, maybe I want to send it off on an angle of like that, right? If it's hitting the center, I want to send it up like that, the ball. And if it's hitting over here, I want to send it over there, and anywhere in between, some sort of scale that will allow me to control where the ball is moving, okay? So if I'm hitting 0, I need it to go straight up. And in SFML, I think the axis is like this. Okay. That is Y. And this direction is X. Oops. That is X. So this is actually minus 90 degrees. Sorry, minus 90 degrees that way. Oops. I really am not a paint expert, that's for sure. That's minus 90. This is like minus 45, or maybe even something steeper than that. Let's say we want this to be minus 25 degrees. And we want this one to be, I guess, plus. Wait a minute, what will that one be? I lost my picture, where is it? Don't let me move over now. Oh, too zoomed in? Okay, no problem. And I want this one to be, wait, if this is minus 90, this is plus 90, right? Minus 25. And then this would be like minus what? 95, 90 plus, why am I so bad at math? There we go. No, 65, Josh. You sure? I had 25 here, right? Yeah, he's right, he's right. Smart guy. 155. Hire this man. Watch this. 155. Okay, cool. So I need it to hit minus 225, minus 155, and if it hits the middle, it's going to go straight up. And the only variable I have is this one right here. Okay, this is the distance. I know that this number goes between minus 2.6 to 2. So I know it goes. So let's do a little bit of math. I have a number that goes from 2.6 to minus 2.6 to 6. Minus 2.6 to 0 to 2.6. And I need it to go from minus 155 to 90 to minus 90 to minus 25. And it's just a linear relationship, right? So what's the conversion here? How do I get from here to here? I guess I probably have to subtract 90. I have to take my variable. Let's just call it x. I'll have to subtract 90 from it. That will give me the 90, right? And then what? I got to figure out how to go from 2.6 to minus 25. What's that, like divided by 10 or something? Josh, help me out here. What's my number?
What? Come on, Josh, do the math. What?
I want to go, I'm doing a linear relationship, but I go from minus 2.6 to 0 to 2.6. But I want my number to go from minus 155 to minus 90 to minus 25. If my number is x, if this number is x, I have to subtract 90. So the 0 will give me what if we do 10 times x minus 90? Minus 10x. Minus 10x minus 90. Is it going to work? Let's look at our calculator. Calculator. Okay. Let's see if this is close enough. So if I go minus 10, oops. Is that how you do negatives in this little thing? 10, and then I times it by, I'm going to do 2.5 instead of 2.6, because I'm hardcore. No, it's not going to work.
Isaac, how did you fix what it's saying body not declared?
You would think, okay, what's 2.5 times, hold on, I'm pausing this till we fix. I'm unpaused. I'm going to take this number, divide it by 2.6, so now it'll always give me a number between 0 and 1, or minus 1 and 1. Let's see if that works. Great. Okay, it's always going to give us a number between 0 and 1 when it hits it. -1 and +1, sorry. Let's look. Just kind of normalized it. There's a -0.83. Here's a plus something close to 1, 0.87. If I get in the center, it should still be close to 0. No, I just normalized it so it always gives me a number between -1 and 1 depending on where I'm hitting the paddle. So that's great. I'm going to take that entire number, okay, and times it by 65 because I need to move either -65 degrees to the left or 65 degrees to the right. And it should be a negative, correcto. And then after I'm done all that math, I should finally subtract 90 from it. So why don't I just go -90 minus that. Hopefully, that should give me a number between -165 in the very left and -25 in the very right. Maybe? Let's look. -25? Ugh, I got it the wrong way. Okay, that's good. I just have them opposite. So, should be 0 degrees if I hit the center. Oh, -90, that's what I wanted. On the right, it should give me -25. So, I got a minus sign somewhere here. Should this be plus? Yeah, there we go. Okay, so if I hit the right side, it should be -25 at the very most, right? Goosh. -50, that's not bad. Take that. If I hit the very edge, I get like close to -25. If I hit the very edge here, I should get close to -165. It's working. Cool. Okay. So now this is kind of like my angle. All right. So I'm going to go float, angle, and I'm going to let it equal all this stuff so I know. Copy. Paste. I don't need to see out it anymore. Every time they hit, it's going to find an angle and it's going to launch the ball in that direction. The first thing we have to do though is make sure the angle is in something called radians. So right now it's in degrees. I have to divide it by this thing called degrees per radians. C++ does not understand degrees. It likes all of its angles in radian. So I have a variable set in physics.h that is able to convert degrees to radians. There's the conversion. Look that up if you want to learn more. But to put angles inside of cosines and sine, they need to be switched into the units of radian measure instead of degrees. Okay, so now all I have to do is set my speed, give it the direction of the angle I'm looking for. So how do we do that? How do I send something off in a direction if I have the angle? It's not hard to do. Let me just start a new page here. File, new. Don't save. If I have an angle like that, okay? Sometimes they use that little fish sign, alpha, whatever. If that's my angle and I want to send something off in that direction, I just give it an x direction of whatever speed I want. So I'll write s for speed. And I write the cosine of alpha. That's my x direction. I also send it in the y direction of my speed times the sine of alpha, and then it will head off in that exact angle direction. If you ever take calculus, you'll learn that, or grade 12 physics.
That's pretty easy.
Okay, so let's send our thing off. We're just going to go body, set velocity, set linear velocity. Oops. Hopefully our angles are right. And we'll just write B2 vec2 because that's what it's looking for. And here we'll give it our speed, which originally we had as 282.4, so I'm going to keep that. That should be a variable, though, down the line. Times the cosine of angle. That's our x direction. Y direction, 282.4 times the sine of our angle. That's good. Only problem is this is in this unit is in pixels, but Box 2D likes everything in meters. So I'm going to just divide this by another conversion factor in here called pixels per meter. If I'm in pixels and I want to be in meters, I just divide by pixels per meter, and the pixels cancel out. It shouldn't matter that much because we already have a limit speed thing in there, but let's see if it works. Let's see if it does the right angle. Zoom out. That's quite a line of code. I might just put let's see every time we hit if it bounces off in the other. If I hit the center, it should bounce straight up. Oh, that's close. Pretty good. If I hit the right side, it should bounce off to the right. Yes. If I hit the left side, it should bounce off to the left. I'm controlling it now. Yes. It's a real brick breaker game now, guys. If I hit somewhere in between, it should bounce off there. If I hit the side, it should probably bounce off something weird. There we go. It acts a little weird when I bounce off the side. We can fix that later. But it's cool. We now can control the ball a little bit better. Makes the brick breaker game a lot more realistic and more interesting. If we can aim where we want to go, right? So there you go. Just did a little bit of math, physics, trigonometry, linear relationships between numbers, all that jazz. And it works out nice. So I'll post that video, have a look. Maybe today